Okay, one more type of problem where we're converting between concentration measurements. So here we have capital M, so be careful, that's molarity. So we need to remember molarity is moles of solute per liter total volume of solution, 1 liter solution. And they're giving us the density, and it's asking for weight percent again. Again, this is really mass percent. So mass percent is mass of solute over total mass of solution, mass of solute plus mass of solvent times 100. So we do know the molality, so like we did before, we'll assume, again, if we have a 1.25, molarity solution, then we can say that we have 1.25 moles of solute, the CuNO3 per 1 liter solution. And if that's true, then we can pull out the solute and say if we have 1.25 moles of the CuNO3 we can convert it to mass using the molar mass. So they give us the molar mass as 187.56 grams per mole. So taking the 1.25 and multiplying by its molar mass, we get 234.45 grams of CuNO3. So if we're getting mass percent, then we just need the total mass of the solution. We know the total volume of the solution is 1 liter. If again we're assuming we have this concentration. So we can go from volume to mass as long as we know the density. Just be careful, we're talking about the total solution here, we're not talking about the water. So we can use the density of the solution that they gave us. So for every 1 liter there's 1,000 cubic centimeters, and then using the density of 1.19 grams per 1 cubic centimeters, this would give us 1,190, and that's grams of the whole solution, because molarity is defined as moles of solute per liter of solution. So now we have the two numbers that we need to get the mass percent. So we simply just take 234.45 grams of the solute over 1190 grams of the solution times 100. And our density and molarity were given with 3 sig figs, so we'll stick with 3 sig figs and say it's 19.7% by mass. I'm going to try to continue with the next problem while we're here. The next one is just arranging based upon freezing point or boiling point. So we have 4 solutions. We have 0.12 molal sugar solution, 0.6 molal calcium acetate solution, 0.4 molal potassium fluoride solution, and 0.6 molal sodium hydroxide solution. So it asks us to arrange from lowest to highest boiling point, so we don't have to actually calculate it. So we'll put our lowest boiling point here, and we'll put our highest boiling point here. So we know boiling point is a colligative property, boiling point elevation. As we have more particles in solution, it raises the boiling point, it prevents it from reaching its boiling point, so it has to reach a higher temperature. It depends on molality and the number of particles. So what we want to do is look at each solute and say, okay, this is a covalent molecule, so it doesn't dissociate. So it breaks into, stays as one particle. So the 0.12 molality is the total molality of the particles. The next one's 0.6 molal calcium acetate. This is ionic. Just be careful with this. This dissociates into 3 pieces. You're always going to have a positive ion and a negative ion. And then you look at the subscripts. So this is going to break into 3 pieces. This will break into 2 pieces because it's ionic, and this will break into 2 pieces because it's ionic. So the this will go to 0.8. This will go to 0.12.